All right, number 13, a recursive formula for the sequence blah is. So recursive formula for this one, huge keywords. We need to know what recursive formula means and what the formula is, or like the setup for a recursive formula is. So as soon as you see the word recursive, you need to be thinking that there are two parts. This is a very common question on the Algebra 2 Regents exams, and that multiple choice answers typically look like these. As soon as you see the word recursive, you need to be thinking that there are two parts, and if you can remember that, you're already down to a 50-50 shot. Choices 1 and 3 only have one equation. When I say two parts, I mean 1, 2, 1, 2. So I'm already down to, literally, like I said, a 50-50 shot between choices 2 and 4. Now the rest of the recursive formula comes from the sequence. So here's the recursive formula. You always have A1 equals the first term. And you can see that both of those already have that, G1 equals 40 and G1 equals 40. So I'm really not concerned about that for this example, but the next part is where it's at. So it's AN equals AN minus 1. Remember, this means the previous term. And then depending on the sequence comes the pattern. It's either adding or multiplying something. So that something is what we need to figure out for this one. So whatever this is. So if you look at your two choices, this one's saying to take the previous term and subtract 10. So aka the pattern is minus 10, and so on. This one's saying to take the previous term and multiply it by 3 over 4. To get from one term to the next term, I noticed that right here minus 10 works, but to get from 30 to 22.5, minus 10 does not work. So you can use process of elimination for this one. That one's out. It has to be choice 4. But you should, while taking the exam, double check your answers. This one's telling you that each time it multiplies by 3/4. So in your calculator, do 40 times 3 over 4, you'll get 30. Do 30 times 3 over 4, you'll get 22.5, and so on. So this pattern does work. It has to be choice 4. All right, moving on to question number 14. It says the J&B Candy Company claims that 45% of the candies it produces are blue, 30% are brown, and 25% are yellow. Each bag holds 65 candies. A simulation was run 200 times, each of sample size 65, based on the premise that 45% of the candies are blue. The results of the simulations are shown below. Bonnie purchased a bag of J&B's candy and counted 24 blue candies. What inference can be made regarding a bag of J&B's with only 24 blue candies? So I'm going to read through my choices. Choice 1 says the company is not meeting their production standard. Okay, not really super helpful to the question, but I'm going to keep reading the choices and leave that one open for now. It says Bonnie's bag was a rarity and the company should not be concerned. Choice 3 says the company should change their claim to 37% blue candies are produced. And 4, Bonnie's bag is within the middle 95 and the simulated data supporting the company's claim. So what I noticed as I was reading through the choices is this is a key word, a rarity. Rarity is another way of saying unusual, which is the word we use most often in class. A rarity is unusual, it's unlikely, so this would mean that it's outside the middle 95, as an unusual event is. And then this one says that it's within the middle 95. As your numbers are either going to be inside or outside of the middle 95, so right away, boom, boom, 50-50 shot. Now we need to figure out what the middle 95 is so that I can determine whether this 24 blue candies is inside or outside of that middle 95 interval. So I go up to the top and I'm hopeful that it has this information. It usually does. And then I have to remember my middle 95% formula. Middle 95% formula is X bar, which means mean, plus or minus 2 standard deviations. And all that information is in that little blue bubble. So my mean is 29.27, and I have to add and subtract 2 standard deviations, which is 3.936. So you subtract first to get the lower value. My lower value when I subtract these is 21.398, and that is going to be through the value that I get when I add them, which is 37.142. So that's my confidence interval, also known as my middle 95%. I'm trying to find out if the value they're referring to, which is this one right here, 24 candies, is within or outside of the middle 95. 24, I don't know why I just wrote a 9. 24 is inside of this interval. It goes from about 21 to about 37, and 24 is on the inside. If it's on the inside, it's this answer right here. It's within the middle 95, so it has to be choice 4. All Number 15, which investigation technique is most often used to determine if a single variable has an impact on a given population? So when you're testing a single variable, for example, a medication, or like that one question we did in class with toothpaste, ingredient X or whatever it was called, you're essentially testing something on groups of people or a group of people compared to another group. So when you're thinking about that in terms of like testing a variable out, I know we use the word variable for X. Try to not confuse that. A variable is just anything that's being tested. To see if it has an impact, you're going to have to go through an experiment. Something that we talked a lot about in class is that an experiment is a cause and effect situation. You, as the researcher, create the cause by giving a medication, giving a toothpaste, giving this, giving that, giving a workout plan. And then you test the effect at the end. So when it's asking if it has an impact, you would have to create the cause, which would be that variable, and see if it has an effect, which would also be known as an impact. So it's choice 3. All right, number 16, as theta increases from negative pi over 2 to 0 radians, the value of cosine of theta will. So it's essentially asking me for the graph. These are two common values on my typical cosine graph, and I need to figure out what the graph is doing between those two values. So I'm going to sketch a cosine curve over here. First, I'm going to label my axes. So obviously this is 0. That's my origin. Then this is pi over 2. This is pi, 3 pi over 2, and this is 2 pi. Remember, those are the values that you get when you go around the unit circle as well. If you already have them memorized, fantastic. If not, just think of it as 1 pi over 2. This is 2 pi over 2, but those cancel. 3 pi over 2, and then this is 4 pi over 2, but again, those cancel and get me a 2. So that's where those values on the x-axis come from. Now, I'm supposed to be graphing this from negative pi over 2 to 0. I didn't graph this with a negative pi over 2, so I'm going to have to extend this and add that in. This is negative pi over 2 over here. So the part of the graph that I'm looking at is from negative pi over 2 to 0. It's just going to be from here to here. So first I'm going to graph my one typical cosine curve. Remember, cosine starts at the amplitude, so I start at the amplitude, hit, down, hit, up. Looks like the letter C. That is my typical cosine curve. Now when I go in the negative x direction, it's going to continue that pattern. So now it's going to go like this, hit, and then the rest of it really doesn't matter. It would obviously continue just like so, but I don't need to know that information. I'm just focused on this part of the graph right here from negative pi over 2 to 0. So if I'm focused on that part of the graph, you need to figure out what it's doing between negative pi over 2 to 0. So it's starting at a value of 0, or a y value of 0, I should say, and then it goes up to a value of 1 because my amplitude for this graph is 1. So it's going from 0 to 1, and it's going up, so it's increasing from 0 to 1. This one's going to be choice 4. All right, number 17, consider the following patterns. Which pattern is geometric? So it's super important that we know what this word is. Geometric means it follows a multiplying pattern. And what's really also important that you remember about geometric sequences is that, yes, it follows a multiplying pattern, but it has to multiply by the same number each time. So it can't be like times 2, times 3, times 4. That's not a geometric sequence. It has to multiply by the same number each time. So like times 2, times 2, times 2, times 3, times 3, times 3, something along those lines. So I have 4 choices here, and I need to test them out. So to figure out what you have to multiply, because these are trickier numbers, guys, to figure out what you have to multiply this by to get to this, it's a little tricky because you don't know really what 16 times what would get you negative 12. What you do is take this and do the opposite and divide it by this. So the rule to find out what you're multiplying by is to take your second number and divide it by your first. You can also take your third and divide it by your second. You can take your fourth and divide it by your third. It'll always work to get you what's being multiplied each time. So to figure out what 16 is being multiplied by to get to negative 12, I'm going to do negative 12 divided by 16, and I get negative 0.75. So what that means is I should be able to multiply negative 12 by negative 0.75. So I'm just going to multiply it by negative 12, and I should get 9, and I do. So now I try again. Multiply again by negative 0.75 times negative 0.75, and I get negative 6.75. So there's my answer right away. I multiplied each one Didn't remember that the first one was the right answer. I multiplied all of them by negative 0.75 and it worked throughout the whole pattern. Make sure you check the whole pattern too. It is a very Regency kind of trick to have the same number being multiplied for the first two and then the third one doesn't work. So always check them all. But one works, that's my answer. My other test taking tip for you is to check the other three anyway, just in case. Some of them are a little bit easier than others. Like the next one, to get from 1 to 4, I have to multiply by 4, but 4 times 4 is not 9, so that one's out. Okay, for the next one, why is this not working? There we go. For the next one, to get from 6 to 18, I have to multiply by 3, and if I multiply 18 by 3, I don't get 30, so that one doesn't work. Next one's a little bit tougher, but you can do the division trick again. So do like 2/3 divided by 1/2 and then try 3/4 divided by 2/3, and you'll notice you do not get the same values. So that one's out as well, which leaves us with choice 1. All right, for number 18, consider the system below. This is a 3 by 3. Notice there's 3 variables, 3 equations. That's what it means to be a 3 by 3. It says which value is not in the solution x, y, z. So even though this is a multiple choice, you still have to solve it to figure out what x, y, and z are, and then the multiple choice answer that does not have one of those values is the one that's not, in the solution. So the trick for this is to pick 2 equations that you can very easily add together to cancel out at least one of your variables. I'm going to choose A and B, and you'll kind of notice what happens when I do. When I choose A and B, the equations are x plus y plus z equals 9. And x minus y minus z equals -1. When I add these 2 equations together, x plus x, remember there's ones in front, that's going to be 2x, and then the y's cancel and the z's cancel, and I'm left with equals 8. When 2 variables cancel, I'm ready to go and solve this completely for 1 variable now. If I can cancel 2, fantastic. I divide by 2, and I get x equals 4. So that means that 4 is in the solution set, so it's not my answer. Oh, good. Why does that keep happening to me? And of course for this one, I'm just going to rewrite those steps so we have them. Okay, add them together. I get 2x, those both canceled, equals 8, divide by 2, and I got x equals 4. Perfect. So I'm kind of a third of the way there, but what I have to do now is solve for either y or z. Usually when we do this, we end up with 2 separate equations, and I can take one of them and plug in because it's only in 2 variables. I don't have any in 2 variables right now, so what I'm going to have to do is add 2 more equations together and just hope that I can cancel out 2 different variables to solve for something other than x. This is different than the typical solving of a 3 by 3, by the way. This is not how they usually go. You usually have to create a 2 by 2. This one just happened to work out because these ended up canceling. So you'll notice now if I pick B and C, I have x minus y minus z equals -1, and I have x minus y plus z equals 21. Now, if I go to add these together right now, only the z's will cancel. However, if I instead, and I'd end up with a 2 by 2, I could create another 2 by 2 and do it that way. To work smarter, not harder, what I'm going to do is multiply my b equation by -1, because watch what happens when I do. This will become a -x plus y plus z equals 1. Now when I go to add these together, the x's and the y's cancel perfect, and I end up with 2z equals 22. So I can divide by 2 and I get z equals 11, which tells me that 11 is not one of my answers. If you did just add them together, z would have canceled. You would have ended up making your first equation for a 2 by 2. You'd have to make another one. It's a lot more steps, especially for a multiple choice, which can happen, guys. Sometimes the multiple choice are very long and require a lot of work. Don't panic if that does happen to you. It can happen. But if you have a situation like this where you can cancel 2 of them, again, work smarter, not harder. So now I know what x is, I know what z is, and now that I know 2 of them, I can plug them into one of my 3 by 3 original equations to help me find the last one. I'm going to plug it into the top because there's no negatives, it's all positive, we're good to go. So the equation is x plus y plus z equals 9. I'm going to plug in my value, this is 4. I'm going to leave the y because that's the one thing I need to find, and plug in the 11 for z. So I get 15 plus y equals 9. And when I subtract the 15 from both sides, I get -6. So if y is -6, that means it is an answer. This one's out. My answer has to be -8. That is the only answer that is not part of my system. All question number 20. If a solution of blah is expressed in simplest a plus bi form, the value of b is. This part tricked a couple people up. We're going to solve it first, and then we'll talk about that value of b. But this is another one of those situations where the multiple choice is a long example. Oh, I skipped number 19. Sorry. Jumping back. I am going to erase this, by the way, though. We need to do number 19 before we do number 20. Fancy that. Okay. So number 19 says, which statement regarding polynomials and their zeros is true? So for choice 1, it says x squared minus 1 and x plus a. I know there's two variables in this. Don't panic. If we're talking about zeros, we are teeing this up and finding the answers. That's what finding the zeros means. But when you find the zeros, you want to make sure that you are completely factored. So there's two different ways that you can do choice 1, and I'm going to show you both of them. If I tee this one up right away without factoring it further, I get x squared minus 1 equals 0 and x plus a equals 0. Kind of a trick to each of them. For this one, I'd have to subtract the a because I'm solving for x, and I get x equals negative a. Now, if I look, that one's listed. But for this one, I'd have to add the 1 to both sides, and I get x squared equals 1. Now, when I continue solving for x, I have to square root it, and when you square root a number, you have to remember this. You get plus or minus 1. That's not here, so this is not my answer. Okay. If you choose to factor it completely first, I think it helps because you don't have to remember that plus or minus. Sometimes we forget those things. This right here is dops. So I'll get x plus 1, x minus 1, and then the x plus a comes down, and hopefully you can already kind of see. If I do x plus 1 equals 0, I get x equals negative 1. Here I get x equals 1, and then same thing happens over here. I get x equals negative a. So I can see right away there's 3 answers, and it's telling me there's only 2, so that one's out. Okay, choice 2 says x cubed minus a x squared plus 16x minus 16a has zeros of 4 and a. This one is very clearly not in factored form. There's not even any parentheses, so that means that one needs to be factored first. So off we go. It is x cubed minus ax squared plus 16x minus 16a. I have 4 terms, so that means I'm going to have to use grouping. So I group each of them. This one has a GCF of x squared. This has a GCF of 16. So x squared will leave me with an x minus a. When I take out a 16, it'll also leave me with an x minus a. This is a good sign because they match, so I get x minus a and x squared plus 16. Now this is not dops because this is not subtraction, so I cannot factor that one again. I'm ready to tee it up. So once again, I get x minus a equals 0. When I add the a to both sides, I get x equals a as one of my answers. This one's saying that's there, so that one's checked off the list. Now for this one, x squared plus 16 equals 0. When I subtract a 16 from both sides, I get negative 16, x squared. And then to get rid of that squared, I have to square root it. Now think to yourself, what type of number do you get when you square root a negative? You get an I. This is going to get me plus or minus 4i, and that is not what's listed here at all, so this one is out. Remember, like I warned you in the last problem, sometimes these questions require a lot of work. Luckily for choice 3, which I'm going to check next, and again, we're on number 19, so I'm bringing this down. I just need more workspace. For number 3, it's already factored, x squared plus 25, and then x plus a. This cannot be factored again, even though this kind of looks like dops. It is not subtraction, so I'm ready to tee it up. I get x plus a equals 0, so I get x equals negative a. And then for this one, x squared plus 25 equals 0. I subtract the 25 from both sides. And once again, I am taking the square root of a negative number. When I do that, I get plus or minus 5i, and this one says plus or minus 5. It just does not have the I, so this one's out. So right away, it's got to be choice 4, but of course, we are good students. We're going to check it anyway. Unfortunately, it's not factored, so I'm going to have to factor it. So here we go, writing it out again. And it's 4 terms, so I'm going to have to do grouping. I wrote that a little sloppy there. So I'm going to group the first 2 together, group the second 2 together, and GCF each group. My first group has a GCF of x squared. My next one has a GCF of negative 9. So when I take this out, I'm left with x minus a. When I take out the negative 9, same thing happens. I'm left with an x minus a. These match, so the x minus a comes down. If only I wrote a little bit neater. Here we go. And then the x squared minus 9 comes down. Now this can be factored again. There's 2 different ways that you can do it. I'm going to continue factoring it. I have x minus a here, and then this is dops, so it's x plus 3, x minus 3. You can also solve this separately when you tee it up. If you do, you get the plus 9 and you get x squared equals 9, and when you square root it, you should get a plus or minus 3. So you just have to remember that plus or minus if you don't factor it again. It's a tricky thing to remember, so just always remember to factor completely and you can't go wrong. So I set them all equal to 0. Here I get positive 3, here I get negative 3, and here I get positive a. So plus or minus 3, which is this right here, and a. So we checked that that one was right. We're good to go. It is choice 4. Fun, wow. So now I'm going to erase these just because I need some space for 20 now. I'm sure there's a faster way to erase this. Sorry if I don't know the faster way. I wonder, nope. If this happens to you on your exam and you need more space, you can always go up to a different question. Like way up here, I have a lot of extra space. You can use all of the space for any question that you need it for. Oh, that was it. I was trying to think of my pun of the day. I'll tell you my pun of the day. I was going to tell you while I was erasing, but I just forgot it until now. Pun of the day. Don't be worried about your smartphone and TV spying on you. Your vacuum cleaner has been gathering dirt on you for years. There's my comedy section of the video. Here comes question number 20, which also requires quite a bit of work. So maybe separate sheet of paper if you guys need it, whatever. So it says, if a solution of blah is expressed in simplest a plus bi form, the value of b is, like I was saying before, this part tripped people up in the past, and we will talk about it once we get to it, but first we need to solve this. It's saying a solution, so it's essentially just telling me to solve, and this is a huge hint that I'm going to end up with a negative under the square root. That is how you get an imaginary answers if there's a negative under the square root. That's also a big hint that there's going to be a square root involved. So if I'm solving something that has an x squared and it's going to end up with a square root, huge, huge, huge hint, I'm going to need the quadratic formula. All right, off we go. So I start by distributing this so I can simplify it out. 2 times 2x is 4x, and 2 times negative 1 is a minus 2, and that equals 5x squared. Now, I typically try to always keep my x squared positive, so I'm going to move this stuff this way. It wouldn't be wrong if you subtracted the 5x squared over, but it's just, this being positive, I don't know, there's something about it, it just makes me happy. So 5x squared, the minus 4x comes down, the plus 2 comes down, and that equals 0. Notice I put it in standard form, so now this is a, this is b, this is c, and I'm going to plug them into the quadratic formula. If for some reason during the exam you panic and forget the quadratic formula, it is on the reference sheet, so you can just flip to that. And now I'm going to plug all of these in. So my x, my equals, and my negative come down. B is negative 4, so I bring down the negative 4, and this is going to become a positive. Then the plus or minus, big square root. In the parentheses, I plug in b again, so negative 4 squared minus 4 times a, which is 5, times c, which is 2. That is all over 2 times a, so 2 times 5. The next part that you tackle no matter what is the part underneath the square root. You're going to type that part into your calculator, parentheses everywhere that you see them. The rest of this is just going to come down. It's 4 plus or minus, and that's over 10. When I simplify that part underneath the square root in my calculator, and again, take your time if you, or pause the video if you need it, you should get a negative 24. Huge, indication that we are doing something right, because I did end up with a negative under the square root, and I was supposed to get an I in my answer, so that's a good sign. But I look at my answers, and none of them say the square root of 24. It's because it says simplest a plus bi form. That means I need to simplify this radical. So the next step I'm going to tackle is still this. So it's 4 plus or minus. When I simplify a radical, I need 2 radicals. The biggest perfect square that comes out of 24 is going to go under this one. So 24 can be divided by a 4. I'm going to put a negative 4 there, and negative 4 goes into negative 24 6 times. So a 6 goes under that one, and this is still all over 10. I'm going to finish simplifying this by taking the square root of negative 4. So it's x equals 4, plus or minus, that'll be a 2i radical 6, and that's all over 10. Now, to put this into a plus bi form, I need 2 separate terms. I need a and I need bi. So I need to split this up, kind of like we did in class with the bubbles here. This is a, this is bi. So when I simplify this, pause real quick. Okay, 4 divided by 10 is what I'm going to simplify first. That'll get me 2 over 5. Plus or minus 2 over 10 is going to simplify to 1 over 5. That I will carry over, and so will the radical 6. Now, here's where that trick comes in. It's saying it just wants the value of b. Really hear me out with this, because a lot of people mess this up. If it just wants b, that means it only wants this, not the I, just the number in front of the I. So I go back to my answer. It wants everything for b that's not the I. So I'm not including this. This, let me circle that a little bit better. This without the I is your b. So it's radical 6 over 5, which is choice 2. Notice there is the I here. A lot of people picked that answer. If it's just asking for b, it wants the part that's in front of the I in a plus bi form, aka just that part. All right, next and last page for multiple choice. So number 21. These ones are a little bit less work if that makes you feel a little bit better. 21 says, which value to the nearest tenth is the smallest solution of f of x equals g of x if f of x equals blah and g of x equals blah blah? Okay, we really need to talk about this because sometimes the answers are tricky. If you have something that says f of x equals g of x, it is asking you where is y equal to y. Your answer is going to be an x value. Sometimes they give 2 answers as points, and if you know right away that the answer is going to be x, you could have eliminated those 2 options. If it was set up like that, this one's not, but we've seen it a bunch of times. So no, if you're finding the smallest solution to where 2 y values are equal to each other, the answer is just the x value. So if you tried to plug these in, if I put this here and I put this here, which is what I've seen a lot of people do on those final exam reviews, it's going to be a nightmare to solve. You have an x cubed, you have an x in it, you have a trig function. We haven't solved anything like that in this class. So that's not going to work. What you need to do is do it graphically by seeing where they intersect. If these are my 2 points, or sorry, those are my 2 graphs, they would intersect at that point. So I'm going to go to my calculator, go to my y equals. The first equation is 3 sine of 1/2 x minus 1. Notice I put my 1/2 in parentheses. The x is still in the parentheses with the 1/2, so I'm taking the sign of that, and then I did the minus 1 on the outside of the parentheses. My next equation is x to the 3rd minus 2x plus 1. Now, a couple things we need to talk about before we hit graph on this. First and foremost is this. When you are taking the sign of something that's not in degrees, 1/2 is not a degree, you have to be in radian mode. When you guys reset your calculator at the beginning of the exam, it will automatically reset you to radian mode, but it doesn't hurt to double check. I am in radian mode. You just go to radian, highlight over it, and press enter. Yours looks a little bit different. If you didn't know what button I pressed to get here, it's mode, right next to second, kind of near the y equals. This is the mode button. So when you press that, highlight over radian, and you'll be good to go. Sorry, you'll be good to go. Okay, so I'm going to go ahead and hit graph. Ooh, so pretty. And I see that it intersects 3 times. It wants the smallest solution. And remember, your answer is an x value. So I'm looking for the smallest x value. Guys, x values are on your x-axis, so you're looking for where it goes furthest to the left. So I'm just going to sketch this really quick. So let me try and stick to the colors. I can't draw on my calculator, so I think this might help you guys out a little bit. Boom, boom, boom. I know that's not perfect, but the smallest x value, this is an intersection point, this is an intersection point, and this is an intersection point. The smallest x value is going to be the one that's furthest to the left. So that's the point that you're looking for, is that one right here that's furthest to the left. That'll be your smallest x value. So to find an intersection point, and I don't think my calculator does it the way that yours does, but just walk through it with my words. You're going to hit second, trace, and then to find the intersection point, you're going to go down to intersect. So my cursor's over there. I'm going to go to the intersection point. It does do it the same way. I didn't think it did. I'm going to the intersection point and I'm going to press enter 3 times. Yeah, I didn't think it would. So again, you guys highlight over the intersection point. Maybe that one worked. What was the right answer? And so again, move your cursor over the intersection point, press enter 3 times, and you're looking for the x value. So if you look at mine, I know it looks a little bit different than yours. It says in like purple there, the x value of this point is negative 2.05497. Yours might be slightly off because your calculator is estimating as best as it can, but if you look at all of your choices, there's only one that's close, and it's choice 2, because this will round to negative 2.1. It did say in the directions to round to the nearest tenth as well, so we are good to go. All right, for number 22, expressed in simplest a plus bi form. Here we go again with the I. Oh, this one's fun. Blah, blah, blah. So I need to simplify this. Woo! It's going to be a good time. Here we go. I'm going to start by rewriting it. This is 7 minus 3i plus, when I have something squared, it means write it twice. So that's what I'm going to do when I rewrite it, is x minus 2i, x minus 2i. I'm also just going to erase this. Get that out of my way. Perfect. I'm going to bring down the minus and then the 4i plus 2x squared. So even though there's parentheses around this one, it's not being multiplied to anything. There's nothing being distributed through to it. Those parentheses are useless, so I'm just going to get rid of them. Plus, the next thing I have to do is multiply these together because I'm adding this whole piece. So I'm going to double distribute. I get x squared minus 2xi minus 2xi, and then a negative 2i times a negative 2i will be plus 4i squared. I'm just going to scoot that over so I have enough space. Okay, now my last thing that I have to do is subtract this last piece. If you're subtracting more than one term, which is shown by parentheses, you distribute that negative through. So this is minus 4i minus 2x squared. Wow. So I need to combine some stuff. So let's look through and see what things I can combine. I have a negative 3i and a negative 4i that I can combine. I have an x squared here that'll combine with this negative 2x squared. Oh, and I have negative 2xi and negative 2xi. I think that's all that can combine, so I'm just going to combine it now. I'm not even going to worry about standard form for right this second. I'm just going to combine my stuff. So I get negative x squared. That means these are gone. Minus 7i when I combine these. When these combine, they do not cancel, by the way. They're both negative, so it's minus 4xi. And nothing else combines right now. But this right here is an I squared. You are not in simplest a plus bi form if you have I to an exponent. And I will say that again because it's so important. You are not in simplest a plus bi form if I is still being raised to an exponent. So you need to know what that I squared is. I squared is negative 1. If you forgot what I squared is, hello calculator, I love you so much. I is second decimal point, and you can just raise it to the second power and your calculator will tell you, hey, listen, it's negative 1. Perfect, because I forgot. So handy. Boom. Now, this is a positive 4 being multiplied by a negative 1. Positive 4 times negative 1 is a minus 4. So if this whole thing right here is minus 4, that will now combine with this. So I do have some more like terms. 7 minus 4 is a plus 3. It's bothering me that that's in red, so I'm just going to change it plus 3. So that combined with this, and we are good to go. I can't combine anything else that is simplified as it can be. So I'm like, oh, cool, I got my answer. I go look at my choices, and guess what? It's not there. None of the answers are written in simplest form either. Ooh, boy. So I think the easiest way to tackle this is to now simplify your answers. So for these ones, the I is being multiplied through, and the negative is being multiplied through to this one and this one. So make sure when you're simplifying these that you multiply all of that through. So what I end up getting for choice 1 is this is still 3 minus x squared, but this will be minus 4xi and minus 7i. So I check to see if that is the right answer by seeing if everything matches up. So when I look through this, whoa, I have the 3, that's right here. I have a negative x squared, that's right here. A minus 7i is here, and a negative 4xi is here. So this looks like it's my answer. Of course, I should check all of them to make sure, but this one has everything I need, so I'm going to circle it for now. This next one, 3 plus 3x squared. When I multiply the negative and the I through, I get minus 4xi and minus 7i. And that one does not match up because of the 3x squared. I do not have that here, so this one is wrong. And then for the next ones, there's nothing to really multiply. It's already written out. These only have 3 terms, and these only have 3 terms. So those are both out. Gone, gone. It's got to be choice 1. All right, next one. Written in simplest form, the fraction blah, where x is not equal to plus or minus 3 is equivalent to. I don't want you guys to get thrown off by this. Some people often do. It's just stating what is excluded from this fraction so that the fraction can be correct. If you plugged in a positive 3 here, it'd be 9 minus 9, which is 0, and you can't have a denominator of 0. Even if I plugged in a negative 3 here, negative 3 squared is 9. 9 minus 9 would get me a 0 in the denominator. All that part of the question is telling you is that if x was positive or negative 3, this fraction would be undefined, so it can't happen. That's just extra info for you. They're the excluded values we did from that chapter. Okay, so when I'm simplifying, thinking back to that chapter, I have an expression over an expression. I have to factor and cancel. So here I go. When I factor the top, it's got a GCF of x. I'm going to take an x out of each of these. When you GCF, make sure you put that GCF out in front, and that'll leave me with an x squared minus 9. On the bottom, when I factor it, it's DOPS. So when you DOPS, you square root each of these, and don't forget the order does matter. So since the 9 is first, the 3 needs to go first. This is 3 plus x and 3 minus x. Now, nothing really cancels right now, but that's because I haven't finished factoring on top. This right here is DOPS. So I'm going to DOPS it, and I get x plus 3, x minus 3, and that's still over 3 plus x, 3 minus x. Now there's a huge thing to remember from this chapter about when things are reversed, and what I mean by reversed is like this and this. Oh, sorry, not that. This and this, and this and this. The x and 3 are just in a different order. When you flip them over addition, x plus 3 and 3 plus x are identical, so they cancel. Anything identical top and bottom will cancel. However, x minus 3 and 3 minus x, let's say that x is 5. 5 minus 3 is 2, but 3 minus 5 is negative 2. The 2's will cancel, but when you flip, like an x and a 3, for instance, over a negative or a minus sign, it replaces it with a negative 1. So look, mostly everything canceled. All that's left is a negative 1 and an x, which means my answer is negative x, so I go to my choices and boom, there it is. If you forgot that idea about flipping and ending up with a negative, you would have got the wrong answer, so be very, very careful. All right, 24, we made it. It says, according to a study, 45% sorry, I dropped my pen. 45% of Americans have type O blood. If a random number generator produced 3-digit values of 000 to 999, which value would represent those having type O blood? So between 000 and 045, what we have to do is figure out the percentage of values between these intervals. Each choice is giving me an interval of values from a number to another number. We're trying to find out what 45% of the total amount of numbers here is. Now this one is tricky. When they're counting 0 as a number, you have to think how many numbers are there between 0 and 999 when 0 is included. So a little bit more basic example. If I'm including 0 for the numbers 0 through 5, there are not 5 numbers. There's 0, 1, 2, 3, 4, and 5. If you count them, 1, 2, 3, 4, 5, there's 6 total numbers. When 0 is included, it counts as a value. So there's 999 plus the 0. There are 1,000 total values here. Now I need to do that same idea with these, find out how many there are in the intervals, and then put that out of 1,000 to get a percentage. Whichever one gets me 45% is going to be my answer because it's asking which interval would get me that 45% value. So between 000 and 045, I have 45 plus this value that's going to be 46 out of 1,000. I'm just going to get these all set up, and then we'll find the percentages. The next one's from 000 to 444. That means there's 444 plus the 1 that the 000 counts as, which is 445 over 1,000. The next one, from 000 to 449. That means I have 449 values plus the 000, which is another 1. So choice 3 is going to have 450 total. If you want to practice one, pause the video and give number 4 a try. Between 0, 0, 0 and 450, I have this 450, but I include that 1, it's going to be 451 out of 1,000. Now, when I do the division on these, like 46 divided by 1,000, 46 divided by 1,000 gets me 0.046. Oops. 0.046 as a percentage means I scoot this over 2 spots, and it gets me 4.6. That's not 45%, so this is out. Okay, for the next one, when I divide it, I get 44.5%. Please actually try these in your calculator. For this one, I get 45%, and for this one, I get 45.1%. So choice 3 has to be my answer. All right, if you guys have any questions, please feel free to reach out. Good luck.